So today our topic is about conditional statements and operators. Okay. So coming to the conditional statements, the different conditional statements are, one is where and the other one is if. Okay. So along with if we'll have like if then, okay, else, do and end. Okay. So where and if statements are the two conditional statements. Along with these two conditional statements, in order to filter the data based on a condition, we'll make use of the conditional operators. Okay. Both conditional statement and operator is used together to filter the data based on a condition. Coming to the different conditional operators, okay, we have arithmetic conditional operators. Okay. We have arithmetic conditional operators like addition, okay, which is plus, subtraction, okay, multiplication is denoted by asterisk, okay, and division by slash, okay, and exponential to the power of is denoted by two asterisks. Okay, these are different arithmetic operators. Next, moving on to the logical operators. Coming to this logical operators, end, okay, end can be denoted as, so you can write end, okay, or you can write as ampersand, okay, or you can also denote it as for end there are only this mnemonic end and the symbol ampersand. Okay, we can write either way. And the next one is or. Coming to or, you can say the mnemonic or the exclamatory mark, okay, or line, okay, standing line for denoting R. We can choose any one. Okay. Next, the next one is in operator, and after in operator, like operator. Okay. After like is and between. Okay. Is and between. So these are the different logical operators. Okay. And the next one is conditional operator. Okay. Coming to the conditional operator, equal to, okay, or you can say EQ, okay, anything. After equal to, greater than, which is GT, okay, or you can denote by like this, and less than LT, or it can be denoted like this, okay. And the next one is greater than equal to, which is GE, or greater than equal to, okay, less than equal to, which is LE, or less than equal to, okay. Next, less than or equal to, greater than or equal to, and not equal to. Not equal to generally you can represent by NE, or see this approximate mark and equal to, or cap and equal to. Okay, we can denote by any of these three, NE or this one or this one. These are the different conditional operators. So in order to filter the data, we'll make use of either where statement or if statement, and we'll along with either if or where, we'll make use of this arithmetic, logical or conditional, any of the operators. Okay. Now, first we'll start using the arithmetic operators. Okay. So let us take the data set. Let us create a data set called test, and into this data set we'll copy whatever data that we have in our SAS help library class data set. We'll copy that data into this test data set. Set from SAS help dot class. Okay, and run. Okay. SAS help library class data set. Okay, suppose if we want to create a new variable, okay, called age, which is equal to updated age, like age plus 10. Okay, so we are incrementing the age value by 10 and we are storing that value in a new variable called updated age. Okay, so created a new value called updated age equals to age plus 10. Okay, so like this, depending on the requirement, we'll make use of the arithmetic operators. Okay, go to Explorer, go to work, open test, see 14 is 24, 13. Okay, so like this. So similarly, if you want to subtract, write here age minus 10. If you want to do multiplication, write here age into. Okay, use this symbol. If you want to divide by 10, then make use of this symbol. Okay. Exponential. Exponential is nothing but to the power of. Okay. For suppose if you want to find out age square value. Okay. So you can write here age 2 asterisk and 2. So it will consider that value as age square. Okay. See, 196. 14 square is nothing but 196. 13 square, 169. 14 square, 12 square, 144. Okay. Square to the power of value. If you want to find age cube, write here age 2 asterisk and 3. Okay. So that it will find the value of age cube. Okay. So like this, depending on the requirement, we can make use of the different arithmetic operators. Okay. Next, moving on to the first we'll discuss about the conditional statement where, and then we'll see how to make use of these operators. Okay. Coming to this where statement, where is nothing but a conditional statement. Conditional statement as in based on a condition if you have to filter the data. Okay. In other words, we can also call as subsetting the data. Okay. Subset is nothing but filtering the data based on a condition that we call as subset of the data. Okay. So by using where statement, you can only subset the data. Okay. But you can't create a new variables or you can't delete the existing observations. You can just subset the data. Okay. Neither new variables can be created nor existing observations can be deleted by using where statement. Okay. So let us take an example to filter the data. Okay. So we'll take the same program. Suppose say we want to filter into this test data set, we want to copy only the male records. Okay. Then how can we write a program? Where. So what is the variable name? Sex, right? Right here where sex equals to m. Okay. See here we are making use of the other operator. Another operator, conditional operator equals to. Okay. So like this, depending on the requirement, along with the conditional statement, we'll be making use of the conditional operators. Okay. Run this program so that only male records will be copied into this test data set. Okay. Suppose say you want to copy all the male records whose age is greater than 14. Okay. In that case, right here where sex equals to m and age greater than 14. Okay. See here we are making use of another logical operator. Okay. And see here also conditional operator. Okay. So like this, based on a condition to filter the data, we make use of the conditional statements and operators. Okay. So it filtered the data whoever's age is greater than 35. Clear?
Yes, Sonia.
Yes, no? Okay. Now, the next one is suppose say we want to filter the data, okay, for all the male records whose age is greater than 14. Okay. Also female records whose age is greater than 12. Okay. Now, how do you write a condition for this? We want to filter for all the male records whose age is greater than 14. Also all the female records whose age is greater than 12. So here we can write a condition or, right? So everyone know about or and end conditions?
Yes.
Yes, no?
Yes, Sonia.
Yeah. Okay. So here, right, where sex equals to f and age greater than 12. Okay. So if this condition is true or whether this condition is true, it will return the data. Okay. See, all the female records whose age is greater than 12 and all the male records whose age is greater than 14. Okay. Now, suppose say we want to filter for the records whose age is 11, 14 and 16. Okay. Whose age is 11, 14 and 16. We want to filter only for these records. How can we write a program for this? Where age equals to 11 or age equals to 14 or age equals to 16, right? So like this also you can write the program or See, 11, 14 and 16. Or you can make use of the operator called in operator. Okay, this in operator you can make use of. So simply write here where age in 11, comma 14, okay, comma 16. Okay. So this also will give you the same result. Okay. So this is how you can make use of the in operator. Similarly, along with in, you have the negative sense also, like not in. Okay. So if you write here not in, whoever's age is not 11, 14 or 16, it will return all that records. Okay. So in other words, you can say not equal to. Okay. Now the next one is the next one is like operator. Coming to this like operator, okay. Coming to this like operator, along with this like operator, we'll be making use of two more special characters. Okay, which one is underscore and the other one is percentage. Okay, one is underscore and the other one is percentage. What this underscore will do is it will count for the characters. Okay, underscore will count for the characters and percentages, irrespective of how many characters, it will return the value. Okay, that is what percentage. So let us start using this like operator. So generally we make use of this like operator in order to get the same pattern data. Okay. In order to get the same pattern data, we make use of the like operator. Same pattern data as in, suppose say I want all the names, okay, starting with A. Okay. I want all the names starting with A. So this is like the same pattern data, right? So write here where name like, okay, where name like character data, no, so we have to keep in quotations, okay, right here A, okay, the name should start with A, okay, it can contain any number of characters, right, but it should start with A. So percentage is nothing but it will not count for the characters, okay. So write here A and percentage so that whoever's name is starting with A and can contain any number of characters, that kind of records it will return you in the data. See, there are only two names like that. Okay, Alfred and Alice, starting with A and can contain any number of characters. Now coming to this underscore, underscore will count for the characters. Okay, suppose say you want all the 5-letter names or less than 5-letter names. Okay, in that case, draw here 5 underscores. 1, 2, 3, 4, 5. Okay. So what it will do is here you have given 5 underscores, right? So it will count for the value 5 or less than 5. So whoever's name has either 5 characters or less than 5 characters, only that data it will return. Run the program. See, if you observe, no name will be more than 5 characters. Okay. So underscore count for the characters. Clear? Now, suppose say here, first 2 characters can be anything, okay, and the third character should be you, and after that it can contain any number of characters, okay. That's what this means, right? So the first, here there are 2 underscores, which means that there should be only first 2 characters, which can be anything, okay. Third character should be you, and and after that it can contain any number of characters. That's what this means, right? So are you clear with like operator and this percentage and underscore? See, there is only one name like that, Louis. Clear? Hello?
Yes, Pavani.
Clear, no? Okay. So now tell me here, if I write like this, can you tell me what names that we will be getting? Like what pattern names that we will be getting? So all the names containing the value, the character M. Got it?
Yes, Pavani.
All the names containing the character M will be getting to the output. Okay. That is what about like operator. Now, want to show you the effect of missing values. Okay, so let us create one data set here. Mm, Okay, so here let us create this data set. Okay, so now suppose that you want to filter for the records whose name is missing. Then how do you write the program? I'll say data CS set from CS. Okay, where name. So you can say where name is missing. Okay, you can say like this. So that now also you'll get the output whose name is missing. Or the other way to say this is where name equals to, it is a character data, right? So maintain blank space in quotations. This is the other way to represent. And where name equals to missing and where name is missing. Yeah, so these are the two different methods. Okay, suppose for character, for numeric value, if you want to filter, okay, then in that case, right here where age equals to dot. Okay, numeric value you will be representing with dot. Okay, where age equals to missing. Clear? So that it will give you all the records whose age is missing. Okay, so like this you can filter for the missing data for a variable. Suppose say you want the data whose name is not missing. Okay, in that case, or age is not missing, then right here not equal to. Okay, where not equal to missing. This is not equal to symbol, no, or else you can say where age not equal to NE. Okay, NE is also there. Cap and equal to, that also you can keep. Okay. Similarly for age, for name, if you want to denote, you can say like where name not equal to, in quotations, blank space. Okay, where name not equal to missing. Okay, now.
Is it only for characters or numeric also?
No, I told you for both characters and numeric, no?
Both. Okay.
Yeah. See here, for if it is a numeric, then you should represent the missing value by dot. If it is a character, then you represent the missing value by blank space in quotations.
Okay.
Clear?
Yeah.
Okay. So this is about where statement. So if you observe in the complete where programming, we didn't delete any observations or we didn't create any new variables. We are just subsetting the data based on a condition. Subsetting as in filtering the data based on a condition. That's it. Okay. Now moving on to the if statement. Okay. Now moving on to the if statement. In if statement, the common thing in where and if also is used to subset the data. Okay. The additional advantages with if is we can create new variables and also we can delete existing observations. That is the benefit. Okay. We can create new variables and we can delete the existing observations along with subsetting the data. In where we can only subset the data. Okay. Now we'll say a small programming. Suppose say we want to same by using where we filtered out the data only for male records, right? By using if also we can do that. Data test, okay, set from SAS help dot class, okay, if sex equals to m, okay, and run, so that it will filter only for male records. Open the test data set. So it will give you only the male records. Suppose say you want all the male records whose age is greater than 13. Same, right here, if sex equals to f and age greater than 13 or 14, whatever it is, okay. See, okay. Now, using if statement. The next one is if and then. But suppose say whoever sex is male and age greater than 14, we want to delete all these observations. Okay. So except these observations, we want rest all the data copied into this test. Okay. In that case, you can write if sex equals to m and age greater than 14, then right here delete. Okay. So that it will delete all these observations and it will give rest of the data into this test. Clear? See, so there is female 14, but there is no male 14 at all. Or else, so actually see here we have 19 observations and here we have only 16 observations, which means it deleted, but we couldn't see the difference, right? We'll say whose sex is M, will delete, okay? So that we can see the difference. See, it deleted all the male records, okay? So like this we can delete the records, I mean like we can delete the observations, okay? By using if and then, okay? The next one is, but suppose say you want to create a new variable, okay? We can also create the new variable by using this if and then, okay? Suppose say if sex equals to M, okay? Then we want to create the new variable called gender, okay? Equals to, and in that we want to put the text equals to male, okay? Now run the program, open this test, see? See if sex equals to M, then gender equals to male. Wherever the sex is M, the gender is male, okay? Now suppose say here whoever sex is F, you want to create, so in the same gender variable, you want to give a value called female, okay? You can do that by making use of else statement. Else, right here, else if sex equals to F, then gender equals to say female, okay? Now you run the program, open this test, see? Okay, you have to declare the length, okay? Because of the output method, it will fix the gender length to 4 characters, no? Because it is reading the first value as male, which is of 4 characters. So it will fix the length as 4 characters. So either define the length here, okay? Define the length of gender variable. Length of this gender variable, dollar, define it as 6. Okay. So wherever the sex is M, it is male, and wherever the sex is F, it is female. We have created a new variable called gender. Okay. Clear? So the same, since we have only 2 values in this sex, one is N and the other one is F, you can say else gender equals to female. This also you can say. Like this also you can write the same statement. Okay. Both are good. Both are the correct statements. Clear about if then else?
Yes, Pavani.
Yes, no? Okay. The next one is if then else. Suppose say based on a condition, okay, based on one condition. So if sex equals to M, okay, then we want to create 3 new variables called, one is gender equals to male, okay, and the other one is order equals to 1, okay, and the next one is race equals to white, okay. So we want to create these 3 new variables based on one condition, okay. Similarly, if sex equals to female, then we want to create 3, again the same 3 new variables equals to female, okay, order equals to 2, and race equals to Asian, okay. So we want to create. Now, in order to do this, we can make use of if, then, else and do statement, okay. If sex equals to M, then write here, then do, okay, do. What it has to do? It has to create this multiple variables, right? So, create this multiple variables, okay, and end. Next one is else if gender equals to female, then do. What it has to do? It has to create these 3 new variables, right? No, if sex equals to, right? Sex equals to F. Okay. Then do create these three new variables. Okay. Now, so whenever you use this do statement, make sure that you are ending the do by this end statement. Okay. Here we are starting do, no? So make sure you are ending the do. Okay. And now end the program. Now run the program. See, gender, order and race. All the three new variables got created. So like this, based on a single condition, if you want to create multiple variables, you can create by making use of this if then do, if then else do and end statements. Okay, clear?
Yes, Pavani.
Yes, no? Okay then. So this is about if and where statement. Shall we continue with the next topic as well?
Yes, Pavani.
So the next concept is trailing methods. Okay. So in trailing methods, we have two different types of trailing methods. One is single trailing and the next one is double trailing. Okay. Single trailing and double trailing. Now, coming to the single trailing, first we'll start with single trailing and then we'll move on to the double trailing. Coming to the single trailing, let's take an example. Okay. So suppose say here we have our input data like this. Okay. We'll create the data set only. Okay. Suppose say we have the data like this. Okay. So here we are going to create a data set called grade with input variables ID, score 1, score 2 and score 3. Okay. So this is one ID and to the same ID, like for every ID they have like three different scores, which is score 1, score 2 and score 3. Let us create this data set. Okay, see here we have created the data set, right? Is there any other way to represent the same data? Single trailing is nothing but reading one observation data into multiple lines. Okay, how can we read this data into multiple lines? Like this. This is first observation. Okay. So rather than representing horizontally, we are representing vertically. That's it. Okay. So in the same line for the same ID, in the same line we are representing three score values. Here what we are doing? Here we are representing the same three score values in three different lines. This method we call as the single trailing method. Clear? Hello.
Yes, Pavani.
Clear, no? With score. Okay. For the second observation also it is the same. Okay. Here I have already prepared. We'll take this. Okay. So same. This is the second observation. This is third observation and this is fourth observation. So in order to represent this data like this, okay, to read one observation data into multiple lines, this method we call a single trailing method. What should be the programming approach? Okay. So if you observe here, here we have three score values under three different variables, right? Score 1, score 2 and score 3. So transforming this data into this type of data means we are reading this three score values into under the same variable score, under one variable score if you observe. Okay, I mean you can give any variable name, but here I have chosen to give the variable name as score. Clear? Here we are reading three values under three different variables. Here we are reading all the three variables under the same variable. Okay. Now let us do the programming for this. I'll copy the same program. Okay. Now check here. Input ID score 1, score 2 and score 3. Here what we want to do? We want to split this three score values into, these three score values we want to split into three different lines, right? So in order to do that, we have to assign that three different variables, okay, by using three different input statements like this, okay, because we want to read into three different lines, right? So how can we read into three different lines? By making use of that many different input statements, okay. Again, if you see here, when we are reading into the same column, it means we are reading under the same variable name. So the variable name also should be same. Okay. Now end the statement with semicolon. Okay. Now, so everyone remember the data step processing? Source. Okay, I'll write the shortcuts only. Source to. When we are reading the data using input and infile statements, we'll have both input buffer and PDV, right? So input buffer, and from input buffer to PDV, right? Okay. And from PDV to output data set. This is the data step processing, right? Now, so after every end of the input statement, you have to place this at the rate. Okay. So why you have to place this at the rate means at the rate now we call as the column pointer. Okay. This at the rate we call as the column pointer. So why to make use of this column pointer? Column pointer, or we can also call it as the line hold specifier. Okay. Line hold specifier. Now, let us start reading the data. Okay, data grade. Okay, so it will create a data set called grade, and by the time when it executes only first statement, it will be an empty data set. Next, what is the statement to execute? Input and ID, right? So by making use of this input statement, okay, it will read the variable called ID. Okay, ID, and here, what is the first value to read? This value, right? So by for ID, so it will assign for ID, it will assign the value called this 10, this value it will assign, right? This is done. Now, is this the only value that is present in the first line of the data? No, right? We also have three more values, right? So until it reads all these three values, I mean, technically until it reaches the end of the first line, it has to hold the same line in the input buffer, correct?
Yes.
Now, so here when it reads the first input statement, so how many variable names we assigned here? Only one variable name. So what it will do? It will assign this first value to that variable. And next, are there any other variable names here? No, right? But here we have the values, but there are no variable names. So what it will do? It will move to the next input statement. But when it reads the next input statement, what happens? Automatically it will move when it hits the input statement again. Second time when it hits the input statement, what is the logic? It will move to the second data line, right? It will move to the second line in the card statement, right? So here also what we have? We have only score variable. So what it will do? In the second line, what is the first value? Score. So to score, it will assign this value. Okay. Now again, because of this input statement, when it reads input statement, what is the logic? It will again go to the new input, new data line, right? Remember?
Yes, ma'am.
Remember, no? So remember the data step, like when we have that name, ID and department, what it used to do, like, so it used to hold the complete, all the variable names in the input buffer, and it used to assign, like when it reads first value, it used to assign to first variable, second value to second variable, and third value to third variable. And it used to send to PDV and then from to PDV to output statement. So once it reaches the end of the input statement, then what it used to do, again, it used to go to the input statement. So again, the process used to start here because we have like several input statements. Okay. So it will keep reading all the input statements. Okay. So when it reads the first input statement, how many variable names? One variable name. So one value it will assign and it will move to the next input statement. So by the next input statement, automatically it will move to the next data line. Okay. Now, but here what is our logic? The same data line, we want to read into multiple lines in the output. So for that, what it has to do, until it reaches the end of the line as in until it reads the last value, it has to hold the same line in the input buffer, right? Irrespective of how many input statements that it is reading, it has to hold the same line in the input buffer. Okay. So because of that, what we are doing is we are placing at the rate. Okay. So input ID, when it reads input and ID. Okay. So what is the first line? And what is the first value? This is the first value. So it will assign this value. And because of this line hold specifier, what it will do is, instead of moving to the next line, it will hold the same line in the input buffer. Okay. Now, when it reads the next input statement, what is the data line that is present in the input buffer? This is the data line, right? So it has already read the first value. Now, what is the second value to read? Score. Okay. Variable to read is score. And what is the value to read? 79. So into this score variable, it will read the value 79. Clear? Okay. Now, so, but we have two more values, right, to read. Now what we have to do, again, we have to hold until it reads the end of the line. We have to hold the same line in the input buffer. So we are specifying line hold specifier. Okay. And after the second input statement, we have to give the output statement. Why we have to give the output statement? So if we are not giving this output statement, okay, what happened? Okay, if you are not giving this output statement, what is the next input statement? Okay, so because of this line hold specifier, it will hold the same first line in the input buffer. Okay, now what is the value that it has read into the score variable by the time when it executes the second input statement? 79, right? Okay. Now, when it executes this input statement, because of the line hold specifier, it will hold the same line. How many values it read? Two values. What is the next value to read? 82. What is the next variable? Score. But score variable is already there in the memory, no? Like in its input buffer or in PDV, it is already there, correct?
Yes.
Variable. So now what will happen? The 79 will get replaced by this 82 because of the same variable name. Okay. So before it gets replaced, we have to send it to the output dataset. I mean like to PDV, and from PDV to output dataset. Right here, output. Okay. So when it reads this ID and score value, what is the next statement to read? So because of this column line hold specifier, it will hold the same line in the input buffer. Because of this output statement, whatever data that it has read till now, it will copy all the data to the output dataset. Okay. So this data is sent to the output dataset before it gets replaced by some value. Okay. In order to form the first observation. Okay. Now, when it reads the second input statement, input and score. Okay. What is the next value to read after 79? 82, right? So this 79 will get replaced by this 82. Here also because of this line hold specifier, again it will hold the same line in the input buffer. Okay. Until it reaches the last value. Okay. Now, right here, output. So now because of this output statement, what will happen? Whatever data that it has read till now, it will send all the data to the output dataset, right? So it will send this to the output dataset. Clear? Now, same input score. What is the value that is present in score? 82. And what is the next value to read? 100. So this 82 will get replaced by this 100. Okay. So here if you specify the line hold specifier, I mean like if you keep the line hold specifier or if you don't keep that line hold specifier, not a problem. Okay. Because this is the last value, right? There are no more values to read. So even though if you place by default, it will go to the next line only. I mean, by default, also there are no more further input statements, right, to read. So what it will do, by default, it will go to the first input statement and it will go to the next line. Okay. Even though if you specify or if you don't specify, not a problem. Okay. You want to send it to output dataset? So write here output so that this value also will be sent to the output. Clear? Hello?
Yes.
Or do you have any doubt? Anyone? Kiran, Shweta, Pavan Bhai, Yojita.
No problem.
Sorry, Yojita?
I have no doubt.
You are good.
It's clear to me.
Okay then, good, good. Okay. So this is how. Now when it reads the second input statement, sorry, when it reaches the last input statement, by default it will go to the next first input statement. Okay. And next line in the card statement or next line in the data. Okay. So until it reaches the last line in the data, it will repeat the same process. Okay. Like this we can create from single observation. Like this we can create multiple observations. Okay. So run the program. See. So this is first observation, this is second observation, third observation, fourth observation. Clear, no, everyone? Single trialing process.
Yes, Pavani.
Okay. Now the next one is double trialing method. Coming to this double trialing method, okay. Let us take an example for this double trialing also. Okay. See here. So multiple observations will be present in single line. We have to split them into multiple lines. Okay. See here. So here we have a data set called state college with variables PID, high temperature and low temperature. Okay. So if you observe here, see, this is one observation, right? PID high and low. So this is one observation. And PID high and low, this is another observation. This is third observation. So multiple observations are present in one line. Now how to split them into multiple lines. Okay. So by making use of two at the rates. Okay, this we call as this also we call as the line hold specifier only or column pointer. Okay, in other words, column pointer. Column is nothing but like this all we call as the column, right? So two at the rates. What it will do is, how many variable names we have here? Three variable names, right? I mean three variables. Okay, so PID high 32, low 16. Okay, so for this three variables, it will assign the first three values. Okay, so by default, what it will do again? Because it has so if there is no column pointer here, okay, so for three variables it has read three values. So what it will do by default, it will start reading the input statement. When it starts reading the input statement again, it will move to the next line, right? Because when it reads the end of the input line, when it reaches the end of the input line, so again it will start reading the input line from beginning. When it starts reading the input line for the I mean, for multiple times, what it will do? It will move to the next line in the card statement, okay? Or else it will move to the next line in the data. But that should not happen, right? So until it reaches the end of the input line, it should not, until it reaches the end of the data line, it should not move to the next line in the card statement. That is the logic. So we can stop that by making use of this column pointer, two at the rates, okay? So PID high and low, PID high and low, it will assign three values to these three variables. It will assign the first three values. Next, because of this column pointer, what it will do is till it reaches the end of the line, okay, till it reaches the end of the first line, it will not move to the second line, okay. So it will assign next three values to the three variables, okay. Next it will assign next three values to the three variables. It is the end of the line, so it will move to the next line, okay. So from next line it will start assigning three values to the three variables. Clear?
Yes, Pavani.
Okay. So if you don't put that column pointer, it will not read this February, March, May, June, August, September, November, December data. See. Okay. So if you don't put this column pointer, it will not read. So it will assign first three values to three variables. And again, since it starts reading the input statement, it will go to the second line. Okay, next line. Clear?
And if we will put one column pointer,
Yeah, and if we put
one column pointer.
No, it will not work.
Okay, let's see.
No.
Okay.
Okay. So it's like the system inbuilt function, no?
Okay.
Okay.
Means that's the syntax. We have to use the
Yeah,
two column
that's
point.
the syntax, yes.
Okay.
Okay. Clear about single and double column pointers?
Yes.
Okay. So this is done. The next one is, okay, let's take an example. But suppose if you have this kind of data, how to deal? Okay. Suppose if you have this kind of data, okay, like this. So so this is all one observation only, okay, but splitted into 3 different lines, that's it, okay, but single observation. Then how to deal with this type of data means, so the single observation, the same, like one observation split into how many lines? 3 different lines, right? So make use of 3 different input statements, okay. Input. In the first line, what variable data that we have? Suppose say this is city and this is state. Okay, city and state are present in one line. So right here city and state. Next, in the second line we have, by using the second input statement, define in the second line what is the data that we have, like temperature, high temperature, low temperature, and average temperature. Okay, and in the third line we have some perception value. Okay, so define that 3 lines by using 3 input statements. Clear? Hello?
Pavani, can you explain one more time, please?
Okay. So here, this is all one observation, okay? But is splitted into multiple lines, but we have to bring it like this, okay? Okay, we have to bring it like this. In order to get like that, we have to make use of how many lines the same observation is splitted into 3 different lines, right? So make use of 3 input statements. Okay. So in the first line, what are the variables that are present? Suppose say this is city and this is state. So in first line we have city and state, right? So city and state are character data values. So put here dollar symbol. And in the second line, what we have, suppose say this is high temperature, low temperature, and average temperature. So we have high temperature, low temperature, and average temperature. And in the third line, what we have? Select some perception value. Okay. Clear? So what it will do? First, in the first input statement, it will read city and state. And in the when it reads the second input statement, in the second line, it is high, low, and average. Third input statement, perception. Okay. And again, since it reaches the end of the input statement, what it will do? Again, it will start going to the next input statement. So next data line. Okay. So it will read these 2 values. When it reads the second input statement, it will read this value. Okay. Clear?
Yes.
Okay. Now run this program. Okay. So we also have one more method to write this. Rather than using 3 input statements, what you can do is split with this slash. Okay. In the same input statement, split with slash, so that it will understand, okay, this is all one observation only, but it will understand city and state values are present in one line. High temperature, low temperature, and average values are present in other line, and perception is present in some other line. Okay. So it will read so it will also read like in the same way. Okay. Clear?
Yes, Pavani.
Okay then.